Hey everyone, welcome back. Fred here at Math and Engineering, and we're going to do another numerical question for you here. We're going to solve for the Newton interpolating poly of a set of data here. Okay, so what we're given in this question, okay, is a set of x values and y values here. But they could also give you a function here instead of the y values, and you would need to plug the x values in to get the f of x values. So in this question, they just give us the y values here. We don't have to solve for them, so that's good. And the Newton interpolating poly essentially is we're trying to find a function that fits it's essentially, yeah, the polynomial degree n or whatever it is. It depends on how many points that we have. Okay, the poly that fits the data that we're given. Okay, so we're essentially finding a polynomial to fit a set of data. And we're going to do it using this table here. Okay, so I've gone ahead, I've written the table out. Okay, and we're going to have, since we have 4 data points here, okay, we're going to have to do 3 columns in our table of divided differences. So the question asks, using a table of divided differences, find the Newton interpolating, poly, for the data, do not simplify. Okay, so what we're going to do is we're just going to do the table first, and then I'll write the formula out for the Newton interpolating poly, and then we'll just fill in the blanks. So that's what the first step that we need to do in our table of divided differences is we need to copy down our x and our y values, okay? So I like to keep the x value on the left side of the table here, and then the next column is going to be our f of x values, okay? So let's start from here. So we're going to write, and give yourself some room vertically, because you do need to write out a little, small calculations, and you can run out of room. So I'm going to give myself a little more room here. So we have -5, -1, 0, and 2, okay? And for f of x, we have -2, 6, 1, and 3. Perfect. So that's the first step. Okay, so the formula for finding the differences here, and I'm just going to label these up here. So you have x1, okay, x2, x3, and x4, and this is going to be f1, f2, f3, and f4. Okay, so it's going to be f2 minus f1. Okay, and I'll just write this f2 minus f1 over x2 minus x1. Okay, so that's going to be the first divided difference input in our table here, and that is going to be equal to, I'll just write that out for you. So we have 6 minus -2 over -1 minus -5. Okay, so that's going to be 6 plus 2 over -1 plus 5, and that is equal to 2. Okay, so that's and we're just going to continue doing that for each entry here. Okay, so the next one is going to be 1 minus 6 over 0 minus -1, and that is going to be equal to -5. Okay, so essentially, and what we can do here is we're just going to start to draw these lines here. Okay, and I'll show you what those mean in a sec. All right, and then the next input is going to be 3 minus 1 over 2 minus 0. Okay, and that is equal to 2 over 2, which is 1. Okay, cool. So we've filled out the first column in our table of divided differences. So now let's go ahead and let's draw those lines again. Okay, so from each kind of input, we're going to draw a line like this. Okay, perfect. So now this is where these lines that we've drawn come into play. So the numerator of the fraction for the second column is going to be the same thing, f2 minus f1. It's always, the top never changes. It's always this one minus this one, or this one minus this one. Okay, so we have -5 minus 2. Okay, so the difference in this one is for the bottom, for the x minus, x2 minus x1, what we're going to do is we're going to follow this line here, and it's going to take us, and we're going to always go down. We're going to go as far down as we can for the line. Okay, so we're going to start here, and we're going to go across, and then we're going to take this line down, and we're going to go across, and that is going to be our x2. Okay, so that is going to be 0. And then we're going to take the line here, and we're going to go up, and then up. Okay, so we're going to keep going up with the lines, and that's going to lead us to -5. And that's going to be minus there. Okay, so we're going to have 0 minus -5, and that's going to be plus, and that is going to give us a value of -7 over 5. Okay, cool. So let's just do exactly the same thing for the next entry. So we have for the f's 1 minus -5, that's the same thing. let's follow the lines here. Okay, so we go down, down, and that is going to give us an x2 value, I guess we can say, of 2. That's our first entry, minus, and then let's take the lines up. Okay, so we go up here, and we're going to arrive at -1. Okay, and that is going to be equal to 6/3, which is 2. Okay, let me just draw some... just kind of separating these here. All right, perfect. And, well, what do we have next? We have the final entry here, right? Because as you can see, we only have 2 terms left. Okay, so we're going to end up with just 1 term in the third column, and that's going to be the end of our table. So let's just start with the numerator. So we have 2 minus 7/5, and that's all going to be divided by. And let's just follow the lines, okay? So we're going down all the way to the bottom. We have 2 minus, and then follow the lines. That's going to take us to the top, minus 5. And that's going to be equal to 17/35. Perfect. Cool. So what do we have here? We did our table. We have all these values. What do we do with them? And that's a good question. We are going to take the first values, and let me just go ahead and start by writing the formula for the Newton interpolating poly. Okay, so the formula for F3, okay, x, and I'll just, below this, I'm just going to write the general form for the formula, but since we have 3 terms, okay, that is going to be b1, okay, plus b2, x minus x1, plus b3, x minus x1, x minus x2, plus b4, right, x1, and I'll just bring this down here, x minus x2, x minus x3. Okay, cool. So that's the formula right now that we have that we're going to need to use our divided difference table to fill in. Okay, and what is b1, b2, b3, and b4? Okay, so b1 is here. This is the first f of x value. Okay, so this is going to be equal to, okay, we'll say this is equal to b1. Okay, so the next value in our table of divided differences in the first entry of each column is going to be our b values, okay? So this value here is equal to b2. This value here is equal to b3. And this value here is our b4. Okay, so now all we need to do is just plug values in. x1, x2, x3, those refer, and we label those at the start, are the values here on the table. And yeah, that's pretty much it. All we need to do is just fill this formula in, okay? So F3 is equal to B1, okay? So we have -2, okay? Plus B2 is going to be 2. X minus, and where's our X1 here? Our X1 is -5, okay? So we'll just say X minus -5 here. Okay, we have B3, which is -7/5. X, it's going to be the same term here, right? Minus 5. And then we have x minus 2, and x minus x2, x2 is -1. Okay, and we finally have, and this formula gets a little bit long, so feel free to just write it on the next line. And then we have our b4 value. Okay, so b4 is 17 plus 17/35, and then we're going to just rewrite this. X minus x1, x minus -1, and then we have x minus x3. x3 is simply 0, so that's just going to be x. And that's it. The question asks us not to simplify. Don't simplify this in the answer unless explicitly told to by your professor, because that's not what they want. They want you to give it. They want the answer in just the general form. Okay, and like I said, I was just going to write the formula for the general form here, which I will do now. So it's fn minus 1. Okay, so if you're given, I don't know, more data points, you just need to follow this formula here. I'm sure you have this, but I'll just write it out. Okay, so that's the general formula that you need to follow here, but this is the answer, okay? Right down there. Okay, so this term here is what they're looking for. That's the Newton interpolating poly for this data that we're given here, and we solved it using a table of divided differences. Thanks for watching.